Hi students. So today we start math question bank 17 and today I'm going to talk about conic sections. Now conic sections are something you may be familiar with, for example the parabola, the hyperbola and the ellipse, and these are very important in various fields. For example, in space mechanics they are also important in problems such as designing of different type of mirrors and so on. And so this is something which you must know if you are planning to go for an math interview type of situation. Now, also, if you are somebody who is asking questions in college admission tests or in STEM jobs, then these are good questions for you, specifically if you are trying to recruit engineers in the space type of field. So, this is something which is very important in space mechanics. Now, let's start with the first question, which is that which conic section is defined by this equation given here, that is y plus 4 square equals 8x minus 3. And looking at this equation, of course, some of you may realize this is a parabola, this type of equation. And let's look at the general equation of a parabola of this type. So if we look at the math definition here, then an equation of the form y minus k square equals 4p x minus h. This is a parabola. And what happens here is that this parabola has a vertex hk, focus h plus p k, and directrix h x equals h minus p. I'm going to define these later graphically, so bear with me right now. But if we compare the parabola which has been given to this particular general equation, we can clearly see that h equals 3 and k equals negative 4 and p equals 2. Now with this particular definition out there, we can clearly see that this parabola has a vertex 3 minus 4, focus 5 minus 4 and directrix x equal to 1. So now of course if somebody has figured this out, you can ask them to plot the particular equation. Now in some cases, if a person is not able to figure out that this is a parabola, still you can ask them to plot this and show what this particular graph is. So here I have plotted this in Excel. Now in many cases nowadays interviews are held in Zoom or Teams. So people have access to things such as Excel on their own computers, and therefore you can ask them to actually solve this problem there. So now this is the equation here, and to plot it what we do is that we write it in a form where y equals some function of x. So we can write it as y plus 4 is plus minus root 8 x minus 3. So I have simply taken the square root of both sides of this equation, and the result is I have got this plus minus here, and then I can take the 4 to the right hand side. That becomes y is negative 4 plus minus root 8 x minus 3. Now if we were to plot this particular value, then we get this equation here. This is the plot of y versus x, and you can clearly see that this is a parabola which is opening to the right hand side. Now if we look at this particular point, you see that the vertex point is 3 negative 4, which is this point here, and also the focus is 5 minus 4 here. The directrix is a line which is x equal to 1. So this is the basic definition as far as the parabola is concerned. Now let us look at some general aspects of the parabola. So the parabola is defined as the locus of a point which is equidistant from a fixed line called the focus and the fixed line called the directrix. So fixed point called the focus and the fixed line called the directrix. So you can see here the point is there which is the focus, in this case this point here 5 negative 4, and the directrix is x equal to 1. So the parabola is simply going to be the locus of the point which has the same distance from this focus and the directrix. Now the directrix and the focus are also equidistant from the vertex of the parabola. So you can see here that if we look at the vertex, this is at the same distance here, that is 2, and here also the distance is 2. So this distance is supposed to be equal for the parabola. Now the shape of the parabola can be changed depending on the type of equation you are dealing with. So sometime you have this in the form that there is a y square and there is a x here, and now you have this in the form x square and there is a y here. So in this case, this particular conic section is there, and the question is basically which conic section is defined by this equation here. So let us now look at this particular general equation for the second type of parabola, and this is x minus h square is 4p y minus k. This of course is the equation of a parabola with vertex hk, focus h, k plus p, and directrix y is k minus p. Now if we take this parabola and we compare it with the general form, we can immediately see that h is going to be 4 and p is 2 here, and y is, and rather k is 3. So this is what I get here. Now this means the parabola has a vertex 4 3, focus 4 5, and directrix y equal to 1. We are going to check this out graphically. Now an important thing to remember is that the sign of p actually flips the face of the parabola. So here p is positive. I think it was positive in the previous example also, but if you put it negative, then the face of the parabola is going to flip. You can check this out in some example yourself. So let us now try to plot this equation. So if we take this equation, we can write it in this form here. That is, we write it in the form y is a function of x. And if we do that, we can easily plot it. So if I plot it, I get this equation here. So this is a parabola which faces upward here. Now, of course, we can see that the vertex here is 4 3, that is this point here. The focus is 4 5, this point here, and the directrix is y equal to 1, which is the red line here. So this is the parabola in the second case. X minus 4 square is 8, y minus 3. Now if you were to put a negative 8 here, then this is going to flip the parabola in terms of the face which faces outward. It's going to flip it. Now let's turn to the second type of conic section, which is also very important. Now remember, one reason conic sections are important is that whenever spacecraft are escaping out of Earth, they can follow different trajectories. Typically these are the hyperbolic trajectories or the elliptical trajectories. So this equation here is a conic section, and the question is which conic section is this defined by. Now whenever you see a conic section of this type, that is x minus 4 square by 9 minus y minus 2 square by 4 equal 1, it's likely to be a hyperbola. So let us look at the general equation of this type of hyperbola. You can see it here, and we can see that if this is the equation, then the center is at hk, vertices are at h minus ak, h plus ak, the foci are at h minus c, k, h plus ck, and c is root a square plus b square. Now with all this nomenclature, we can compare these two equations here, and I can immediately see that h is 4 here, I can see that k is 2, and therefore I can immediately calculate the values of c. For example, I also see that a is 3 here, that is 3 square would be 9, and b is 2, that is 2 square would be 4. So c would be a square plus b square, that would be 9 plus 4, that would be 13. Now with this particular information given to me, I can easily write the center as 4 2, the vertices at 1 2 7 2, and the foci here. Now let's again try to plot it. This is the question which should immediately follow if the person has figured out what conic section this is. So before we plot it, we have to rewrite this equation. So what we do is we try to rewrite it in the form y is a function of x. And to do that, what we do is we take this x part to the right hand side. So we write it in this form here. And then we move the 2 here, the 4 here. And so we get this particular equation as far as y is concerned. And now if we put it in this form, we can very easily plot it. You can plot it by hand, or you can plot it in Microsoft Excel. Now I've plotted this in Microsoft Excel. I actually had to make two plots and I have superimposed here. There may be better ways of doing this. If you are a smart guy, you can do it, and please let me know in the comment section how you did it. So this is the function y is f of x, and there are essentially two figures which come out. That's very typical of a hyperbola, and we can see that the center is 4 2 here, the vertices are at 1 2 and 7 2. So That's what happens in a typical hyperbolic situation. Very nice looking figure, and you can check it out yourself. That would be a good exercise. Maybe if you are somebody who writes code, you can write a code in Python or some other language to also plot these things, for example in Matplotlib. Now let's try to look at the different hyperbola which is possible. That is, if we have the equation of the form y minus 4 square by 9 minus x minus 2 square by 4. Remember, in the previous equation which I was dealing with, the x was here and the y was here. So this is somewhat of a flipped case. And again, we want to find the conic section represented by this equation. Again, like I mentioned before, this is likely to be a hyperbola. So this is the general hyperbolic equation for this kind of equation, that is y minus k square by a square minus x minus h square by b square equal to 1. And again the center is hk, the vertices are h, k minus a, hk plus a, the foci is h, k minus c, hk plus c, and c is root a square plus b square. I look at this equation very carefully and I can immediately see that h is 2, k is 4. By comparing these two equations, I also see that a is 3, b is 2, and c is root 13. So I am immediately able to obtain the center, the vertices, and the foci of this particular hyperbola. Now, of course, the next step is I am going to try to plot this. So to plot this again, I write this equation out and then I want to express it as the form y is a function of x. So to do that, I take the term involving y on the left hand side and all the term involving x on the right hand side. Then I take the square root and I take the 4 to the right hand side here. So I get this equation here. Now this is something which I can plot. I can plot this in Microsoft Excel, which I am going to do in the next slide. So that's what I have done here, and so the plot comes out like this. Now you can clearly see the center is at 2 and 4, that is 2 and 4 here, and the vertices are at 2, 1 and 2, 7. So there is one here at 2, 1 and then one here at 2, 7. Again, this is a typical hyperbola. It essentially always contains two curves and they face out in different directions. Now you can of course get different curves also of forms like this here, depending on the various values which are out there for the different numbers. Now let's turn to the next conic section, which is also extremely important because this is something critical in, for example, Kepler's laws of planetary motion. And you guys all probably know that whenever planets are revolving around a particular sun, or if there is a satellite revolving around the earth, they typically follow a path which is known as the ellipse. So that's the question here, which conic section is defined by this type of equation. Now whenever you have this plus sign here, that is telling you that this is likely to be an ellipse. So let's look at the general equation here, which I have given in purple. You can clearly see you have x minus h square by a square plus y minus k square by b square equal to 1. This is the general equation of an ellipse, and this ellipse has center hk, vertices h minus ak, h plus ak, and the foci at h minus ck, h plus ck, and c is root a square minus b square. So by looking at this equation here, I can easily make a comparison that h is 4, k is 2, and I can also see that a is 3 and b is 2, because see here 9 is going to be 3 square and 4 is going to be 2 square, and I can get c is root 5 because I have here 9 minus 4, that is 5. So with this particular set of numbers obtained, I can write the center as 4, 2, the vertices at 1, 2 and 7, 2, and the foci given by this particular value. Let's check this out by plotting this particular function. Now to plot this particular function, I need to take this and I need to write it as a function of x. So y is this function of x. So to do that, I have taken the equations or the term involving x to the right hand side, and then I have expressed this in a simple form like this here, and then I have again plotted it in Microsoft Excel. Now you can clearly see this plot has come out to be a very nice closed figure, and this is of course known as the ellipse. And you can see here the center is at 4, 2, this center point is here, and the vertices are at 1, 2, and 7, 2. So this essentially is the typical path of a satellite as it revolves around the Earth, or it may be the path of the planet as it revolves around the sun, and so on. Very important in space mechanics and Kepler laws. Now, of course, what I have given you here are the simple forms of the equations, which are often useful in tests, interviews, and so on. But there are more general and complicated form of the equation also, which we often need to consider in various space mechanics problems. And in fact, I have done a video on conic sections as far as the different aerospace and space mechanics aspects are concerned in one of my courses or one of my lectures, and I'm going to put that in the end screen. I'm also going to leave it in the description box. If I forget to leave it in the description box, please remind me in the comments and I will do so. So that will certainly help you figure out the importance of conic sections. Now, many people are very perturbed when they study these things in their high school. Many parents think, why the hell are their kids studying conic sections and so on, and where is it ever used in life? Well, if you are going to become somebody who deals with space, deals with rockets, deals with satellites, then you are going to require conic sections. And also somebody who, for example, makes telescopes and so on, then the parabola becomes very important. So as far as the hyperbola and the ellipse are concerned, these are useful in space mechanics. Parabola is of course very important in different form of mirrors and so on, which can often be used in telescopes and different equipment. So that's where the conic sections become very important. Now, of course, I will end this video now and I will see you in a lecture sometime soon. See you then.